Hey AP Stats, here we are on day 2 of section 6.3. Man, there's such big concepts in this section. I can't emphasize it enough. Okay, so long paragraph here. I'm talking about Settlers of Catan. It's a board game. The game can change significantly if someone rolls the dice for their turn and the sum is 7. Basically, if one of your so-called friends while you're playing rolls a 7 on their turn, they might get a game piece called the Robber, and they might put it on part of the board that negatively affects your ability to be competitive. It'll probably stay there until you roll a 7 and move it elsewhere, and then you put it on one of your friends' thing, and you're no longer a good friend either. The probability of rolling a 7 on any turn is 1/6. If 4 people play, you have 3 opponents. They're not your friends. Let's look at the first round of players' turns, where the game starts and gets moving along. Your 3 opponents will each have a turn for a total of 3 turns. On the first round, 3 people, there will be 3 rolls of the dice, 3 turns. Let X equal the number of 7s that gets rolled by your opponents in that first round. Verify first that the 3 opponents serves as a binomial setting. Binary. I'm gonna click yes or put a check there, and I'm gonna say yes, it's a 7, or no, it's not a 7. So I'll put a 7 right there. Independent. All rolls are independent. Doesn't get more independent than rolling dice. Okay, n, the number of trials. There is a set number of trials. N is equal to 3. We're talking about 3 turns here. And the probability of success each time we roll is the same when I'm rolling dice. It's 1/6, so P equals 1/6. Okay, fill in all of the probabilities for X in the binomial probability distribution. There could be 0 7s. There could be 1 7 2s. That's not how you spell 2. There we go. There it is. This year has gone on way too long. 0, 1, 2, and 3. Okay? Those are the possibilities for X, not the probabilities. Use the formula for binomial probabilities to find each of these 4 probabilities. Okay, the probability that X is equal to 0 is going to be equal to 3 things, 3 options, 3 rolls. Choose 0 successes. It'll be 1/6 to the 0 and then 5/6 to the 3. That's how that's going to go. I can put it in the calculator like this. I can go 3, math, probability, choose, 0. Okay, that's 1, by the way. I'm going to hit enter. It's just 1. There's only one way to not get any 7s. You don't get any 7s. So it'll be 1 times 1/6 to the 0. That's just 1. And then times 5/6 to the 3rd. Okay, that's 0.5787. Well, let me move on to the probability that X equals 1. I guess we could put this up here, 0.5787. More than 50% chance that nobody rolls this 7 on the first roll. None of your opponents, anyway. This will go 3 choose 1 times 1/6 to the 1 and 5/6 to the 3. That's 3 times 1/6 times 5/6 to the 3rd. I put it in the calculator and I get 0.3472. So I have a 0.3472. Now between these two, I'm already at 0.8, 0.9 really. So there's not much probability left for these two, but I'll write them out anyway. The probability that X equals 2 is equal to 2, nope, that's not right, 3 choose 2 times 1/6 to the 2 and 5/6 to the 1. Okay, I put that in the calculator and I get 0.0694. So there we go, 0.0694. And I'll do the last one, the probability that X equals 3. Well, that would be 3 things, and all 3 of them are successes. There's only one way to do that, too. That would be a 1. And this would be 1/6 to the 3 and 5/6 to the 0. And so it's 1 times 1/6 to the 3rd. That ends up being 0.0046. And so I have a 0.0046 up here. Those should all add up to 1. If they don't, it's because I rounded along the way. It'd be off by just a little. Create a histogram to display the binomial probability. All right, we've done this a couple of times. No big deal. There's a 0, a 1, a 2, and a 3. The biggest probability I have to go find is 57, so I'll go 1, 0.2, 0.3, 4, 5, 6, 7. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Didn't even have to go all the way up to 7. This is the probability. This is the number of sevens. This is Catan. None of your friends are really your friends. Okay, so for 0, it goes up to 0.57. It goes like that. Anybody who's played this game before knows exactly what I'm talking about. 0.34 goes right here. 2 is 0.06, so that's like down here. And then 3 you can't even see. Okay, there's our probability histogram. And when we do a histogram, we should probably talk about shape, center, spread, and stuff. The shape, which I misspelled right there, that's pretty ugly. We're definitely going to call this skewed right, aren't we? Skewed to the right. The center. The spread. These are things we're going to want to talk about. I could take a guess here and say it's somewhere around 0 or 1, right? So we're just going to go like this. I'm going to say 0 to 1 somewhere. And the spread, I'm not even going to talk about the standard deviation. Okay? Let's go to the second page. And let's see what happens here on the second page. Find and interpret the mean or expected value of x. Okay, I don't want to write those probabilities out to 4 decimal places. So I'm going to round them to 2. So there was a 0, and the probability of 0, if you look at your last page, was 0.57 something. I'm going to go times 0.58. And then it'll go 1 times 0.35. And then 2 times 0.07. And then it'll be 3 times 0.005. Okay? Multiply every x value times its probability, and I get 0.505. So, if that's a mean, I'm going to interpret it, but that's the average I expect to get if we go through tons of rounds of 3 people, right? We expect 7 to come up, on average, not even once, half of 1, if that makes sense. So, here we go. After heroically playing Catan, playing the first round, let's just say playing the first round many times. After heroically playing the first round many times, we expect the average number of sevens to be mu of x equals 0.505. After heroically playing the first round with 3 opponents many, many times, we expect the average amount of sevens that our opponents roll to be 0.505, which means frequently there's going to be none of them. All 3 of them don't roll a 7, they roll something else. Every now and then there will be 1, maybe there could be 2. But if we add up all of the numbers of sevens that come up over doing this experience many times, we expect the average to be 0.5. Find and interpret the standard deviation. Okay, that's write small, people, write small. Here we go, big giant square root sign. Let's see how big that needs to be. We're going to go 0, the first x value, minus 0.505 squared times its probability 0.58. I need to do this 8 different times, right? Sorry, 4 different times. So the second one is going to be 1 minus 0.505. That gets squared, and it's times 0.35. Then the third one is 2 minus 0.505. That gets squared, and it's times 0.07. And then 3 minus 0.505, and it's squared, and it's times 0.005. Whew. That was a lot. So I'm going to write the answer down here. It's equal to 0.65. The standard deviation of x ends up being 0.65. Our interpretation, okay, after playing many first rounds, of Settlers of Catan, we expect the results, or the number of sevens, let me put it that way, the number of sevens to differ, because a lot of times it'll be 0, right? It's gonna be different by 0.5, a lot, to differ from mu of x equals 0.505 by an average of 0.657. Oh, that's a discrete random variable, and that's how we find the mean, and that's how we find the standard deviation, and that's how we interpret the mean, and that's how we interpret the standard deviation. And my goodness, does that take a long time. I'm tired of that. I hope you guys understand it after doing it this many times because I'm tired of doing it. Number 7, find the probability that your opponents roll at least 1 7 and cold-heartedly put the robber on your part of the board. They are not your friends. Okay, at least 1 7. Well, that means 1, 2, or 3 7s, right? So I could add all 3 of these up. Or, don't we have a trick for at least 1? The only way to not have at least 1 is to have none. See, I'm going to add all 3 of these up. That's the only one left off. So I can just go 1 minus 0.5787, and I'm going to do that. 1 minus 0.5787 will get the job done quicker than adding all 3 of those up. So 1 minus 0.5787 on my calculator is 0.4213. That's the probability that when I play this game, that one of my opponents, who claims to be my friend, that's why they wanted to play this game, they're going to roll a 7, they're going to put their robber on my thing, and then I'm not going to be able to play. I'm not going to be able to get any cards, build any settlements, or anything. They're not your friends, people. Okay, 2 outstanding calculator tricks. You're going to love this. Are you ready? Trick number 1. The binomial PDF. The binomial PDF function calculates any individual probability. Let me tell you what I mean by that. It calculates an individual probability. I don't have to do all this. It calculates an individual probability. There's a function in our calculator that does all of that work for us. Well, now we're talking. To find it, hit second and variables. Second and variables to get to the distribution menu. Okay. Scroll all the way down until you find binom PDF. It's quicker to scroll up, actually. Okay, so look. I could scroll down until I find binomial PDF. Hey, there it is. Then I'm going to hit enter. Now, my calculator asks what values I want to put in there. Some of your older ones will just go straight to the home screen, and I'll show you what you're supposed to put there. You got to fill in values for n, the number of trials, p, the probability for success, and x, the number that you're looking for. If given a prompt menu, or if you have an older calculator, the binom PDF will just kind of show up on the home screen like this, and you've got to put in the n, a comma, the p, a comma, and the x. You guys are probably getting used to putting stuff like that in. Okay, so let's go. I want to find the probability that in that first round, that 2 7s get rolled. Okay, so there's trials is 3. Probability is 1/6. I'll type it in as a fraction. I want to know the probability that 2 7s get rolled. I hit enter, and look, it shows up like what happens with the rest of you guys. If you don't have the pop-up menu, you just go straight to this. The only issue is you got to know that you're supposed to put in 3 things or it gives you an error. So you'll have to memorize what things you need to put in there, right? So I'm going to hit enter. I get 0.06944444, 0.06944444, 0.069.444, 0.0694444. That math gets done that quickly with the binomial PDF function on your calculator. Second and variables, and scroll down until you see PDF. Gotta like shortcuts, people. Let's go to the third page. Third page. From the last page, we calculated the probability that x equals 1 to be 0.3472. Find that probability using the binomial PDF. All right, here you go. Probability that x equals 1. This is how you show your work for this, by the way. If we do a paper test and you got to show your work, this is how it's going to go. I'm going to write binom PDF of 3, because one round is 3 turns. 1/6, that's the probability of rolling a 7. And then 1, because I was asked to find the probability of 1. Second and variables. Now watch this trick. Instead of scrolling down, I scroll up, and I see it on the screen already. It's about the same, actually. Okay, trials 3, 1/6, and I'm trying to find 1. Hit enter, and you get 0.3472. 0.3472. That's what we got when we did the work on the last page. Okay, by the way, the PDF and binomial PDF, it stands for probability distribution function. The next one we're going to deal with is called the the cumulative distribution function, and the word cumulative will mean more to us than what PDF means to us. Okay, so I'm going to stop the video here, and we'll move on to the next one.